Hi, so yes, this is the part three, and I hope you have seen the part two of this video. Please take a look at it. We were talking about this table, or should I say, the non-SQL data. How our huge number of these data will be handled by the database. We were talking about it. So now we have a data. We have so many data, so many entries here, and as we're going to be dealing with like what 50 million users every day. Their messages will be stored in different servers. um, Maybe this could be node 1. This could be node 1 meaning server DB server number 1. This could be node 2 meaning DB server number 2. um, Node 3, node 4, node 4, and then let's say we have like what 4 servers or 4 nodes now. Um, each of these are different servers, and these entries will be stored based on some key that we're going to be finding. These entries are going to be stored or distributed between different nodes. Now, different nodes, or should I say different DB servers. Now, you might have a question right now, hey, why are we making this circular shape? Um, well, if I try to explain it now, it's going to get even longer. But I would say, please take a look at the concept consistent hashing. Consistent hashing on the internet. Um, if you don't understand it, if you haven't encountered it, but for the sake of simplicity, um, we will assume that, okay, we've got a bunch of servers, it's going to get distributed, right? These values. So, for example, I want the combination of from and to as one of my primary key. So this is like one of my primary key. Based on that, okay, based on, let's say first entry, based on these two entries, I will make a key. And based on that key value, I will know exactly which node to look for. Let's say this key indicating that, okay, you will be assigned in this server. So this entry will move to this server. Similarly, Jack and Jake, let's say both of them combined, you make a primary key. And this, based on this key, you would say that, okay, I found that this key belongs to node number 4. So it's going to go down and be stored in this and be handled by this server. You would also notice something that in the message ID, what do we mean by the message ID? The message ID, what I mean by is that it is actually a local sequence number between Jack and Jake. This is the 101th message that they have been contacting with them, right? This is the local serial number, you could call it the message ID. What message came after what between which users that we talked about, right? For example, okay, we've got another Jack and Jake. They have a key, they are being stored in the node 4, or should I say DB server number 4. And this is, like, you see, serial after 101, it's 102. That's how it works. Now we have similarly, it's the same way it's going to work like that. So the point of introducing these servers is that we're distributing these data entries by different servers, because one server cannot handle, um, if you consider 50 million entries each day. I mean, think about it. One server cannot handle it, right? Different DB servers need to play that role. What are we actually doing by doing this thing? We are actually horizontally sharding, or should I say horizontal scaling. That's what we're doing. Horizontal scaling. It's happening here. Where where the where actually where we are um, distributing database into different DB servers. And NoSQL DBs are actually uh, the best at doing these horizontal sharding, or should I say horizontal scaling here. So I hope it makes sense how it's actually stored. I tried to make it very simple. Um, Please look on, if you don't understand consistent hashing, please take a look at the internet to understand about it. I might make videos in the future, but uh, if you want to know why are we, drawing this circular option, you know, then you would just go on and try to, find the answer. What is consistent hashing and how it's actually doing this. So enough of the DB talks now. Um, Now we're going to move on to the workflow again. The workflow, now we're going to work on the workflow of the offline case. We did see the workflow for where both of the users are actually online, right? Now, what if one of the users, is suddenly offline? They were online. One of the users is suddenly, let's say, offline. What's going to happen in that case? What's going to happen in that case? Let's take a look at the workflow here. This is the offline. One of the users is not available. Now, suddenly, assume that okay, user 2 has had a bit of a connection disruption in the WebSocket and also its server. So whenever that happened, user 2, or should I say, let's assume that the electricity, so where the user 2 resides, the electricity is gone now, the user is offline. What's going to happen? The WebSocket is going to be gone. There won't be any sort of a connection pool between the server and this user client number 2. And so, with the result of this, what's going to happen? The chat server will be open. It was earlier we saw that this user 2 was assigned chat server number 1, and it was also noted in the map. Now, since the user 2 is gone, this chat server will be open, right? This chat server will be open. Shouldn't cross it actually. It's open, okay? It's not block, I guess say. It's open, and so what's going to happen? In the map, you know that inside the map, the entry where user 2 was assigned to chat server number 1, it will be canceled, right? It will be canceled. So in this case, in this scenario, user 2 is not online, it's an offline. In this scenario, if user 1 wants to send a message to user 2, what's going to happen? What is going to happen? Let's take a look at it. What's going to happen is, okay, let's say, okay, user 1 sends a message. It is connected. We know it's server, right? It's chat server number 2. So it goes to chat server number 2. Hey, I need to send it asks chat server number 2, hey man, I need to send a message to user 2. Now this chat server number 2 analyzes and says that, okay, I don't have user 2 in my territory, so I have to find out whether user 2, which server user 2 is actually being served by. So what happens is chat server will move to the mapping service and asks and gets the track of user 2 entry, but it sees that, hey, I don't have any user 2 entries available. Now, where do I put it? Where do I put those entries? Which server? I don't know. It's not even being assigned. You're asking me. User one is asking to user two, me to send message to user two, and I don't even know where user two is going to be assigned, right? Because inside the map there's no entry, meaning that the user is actually offline. In this case, what will chat server number two do? What do you think? Well, chat server number two is going to do is, okay, since I don't have an option, I will do what I usually do, which is save my data into the database. I will save that data. That, okay, there was this problem that came, I didn't find whatever. I want to save the entry into the DB, and it goes, and it finishes its work. Nothing happens. Now, after some time, let's say after 1 hour, the electricity came back. User 2 logs in. User 2 logs in. Try to understand. User 2 logs into the application, and it is then connected. HTTP connection established with the user mapping. Now, as a user 2 logged in after a while, uh, you know that it's not going to have its previous server, so it's going to be allotted with a different server. It could be, let's say the situation is currently we're in a state where only chat server number 3 is available for user number 2, and user mapping decides, okay, mapping service decides, okay, we're going to give you chat server number 3. Okay, then chat server number 3 being assigned for user 2. This is the chat server number 3 being assigned to user 2. Now, um, uh, after that happens, what will chat server number 3 do? Chat server number 3 will um, fetch data from the DB, and it will see, hey, is there any message that was received by user number 2? And then chat server number 3 will see, okay, yes, there was a message that was sent from chat server number 1, uh, eventually user number 1, and this was the message that was stored. Let's say this was the message stored by chat server number 2, actually, sorry. So it will fetch it. Once the server is assigned, the server's first work that it's going to do is going to fetch if any unrecognized, if mm, any message that it didn't receive before uh, has arrived. So then chat server number 3 fetches that data, and based upon that, okay, these are the data that user 2 needs to see, so it just passes those messages. So that's how actually the data passes from user 1 to user 2. This is the case for, when one of the users is offline. So that's the thing, you know. Now, I think there's something else. Let me see. Okay. Mm, yeah, I think this is the group one. Okay, this is the group one. Okay, so okay, let's take a look at the next one. Now we're gonna take a look at the group case. Uh, what's gonna happen when we are dealing that same thing, but let's say a user is about to send a message, but the user wants to send that message to a group, uh, to his or her group. So what's going to happen in that case? So this is the workflow of group. How does messaging happen in group? Sorry. Okay, yeah, Yes, that's the one. Group message support. That's the workflow of group message support. So, um, what happens here? Hmm. Okay, so yeah, this is the final one, the group one, the group messaging support. Now imagine, I'm imagining that this support, that this workflow is, um, I'll be explaining this support when every user of a group isn't online. None of them is offline. That could be an assignment that you could do. That what would happen if some of the group members are offline and one user wants to send a message. Right now, for this thing, imagine user one, user, imagine user one wants to send um, messages. Let's see. Yeah, user one wants to send messages to all of the members of its group who are actually online right now. Okay, just think about it. And so, how will the workflow look like? Let's say we have all. Okay, for group, I can create a service that will do the simple CRUD operation. For user, I can also do the user task, user CRUD operation. That is just very basic when you build these applications. But I just want to talk about the workflow here. Let's say user one is available, and user one is our client. Using WebSocket, it sends a message, and inside that message, it has mentioned um, which group it's gonna send the message. So that's a G1, and message type is group type. So let's say this is the group type. The message, some messages written. So user one using WebSocket first. Let's say we already assume that user one has been assigned a chat server. So comes to that particular chat server. Let's say I at chat server. Okay. Or let's just assume about it. Let's say chat server number 33, right? So comes the message, and then chat server 33 sees that, okay, I have to send a message to a group. A group, I have to send a message. So what will it do? This chat server number 33 is going to go to the group itself to find out group's information. To this group service, it's going to talk to this group service and say, hey, I need to find out how many members are there in the group other than the user number one, and who are they, what's their information. I want to know everything. So fetching from the database, um, group's information, group's members information is going to be fetched. Group chat server 33 now has the information of group members. Let's say they are user number 2, user 3, user 4, and user 5. So these 4 users are in the group, and chat server 33 now wonders, okay, I have to send message what user number 1 has sent to each and every one of them. How do I do that? I need to find each and every one of their servers, right? Because we're talking about the scalability. You're talking about scalability. Each of them will have different servers. I need to find them. How do I find it? I have the user mapping service, right? So user chat server number 33 is going to talk to user mapping service about fetching their server, each and every one of their server. So what's going to happen? User 2, user 3, user 4, and user 5, all of their map values. See the map value that we talked about before in the previous workflow, where we had stored which user is going to be assigned with which chat server. So that's what it's going to try to find. Chat server number 33 is going to try to find what are the chat servers of user 2, user 3, user 4, and user 5. So it fetches those. And respectively, uh, chat server number 33 sends those messages to each and every chat server assigned to each and every these members of the group. Also, it saves the messages into the NoSQL database, right? So that's how it actually sends the message. Now, I have a task for you to think about, which is, what if this chat server number 33 finds out that, hey, uh, these user 2 and user 3 are not online. They don't have any chat servers. What are we going to do about it? I have a hint that I think I have actually talked about it, how we're going to deal with it before, but now there's multiple users, so uh, it's basically the same thing that's going to happen, but still I am assigning you a task to think about it, what's going to happen in that case. But in the happy flow of this group service, um, where everyone is online, this is how it's going to work. That's how each and every users are going to get their message. So uh, yeah, that's how it's going to work. Uh, Again, user 2, let's assign it to chat server number 2. Let's say it's chat server number 30, it's 40. Let's say this is 72 chat server number. Each and every one will get the message from the user 1, eventually from actually chat server number 33. So that's why we have two bidirectional uh, mappings here, right? There you go. And hmm, this is the part that I think I previously talked about, this user login and user mapping server. When a user logs in, it talks with the user mapping service to find out what is its server number in the mapping, or it gets assigned with its own server number. I hope that makes sense. But the thing is, that's how it's going to work in the group setting. Now, we've got one last thing to cover, and that is presence system. Presence system. You see this, I've seen something, I've written something called Redis. So basically, instead of memory, I have said that, okay, it will talk to a Redis. Redis is a in-memory key pair value database. If you don't know anything about Redis, just imagine that it's kind of a map. Okay, that's storing our data. What is this? It's storing? It's storing which server is being assigned to which user, like the previous one that I said, like this, right? So just imagine that. But for further exploration, please take a look at what it's all about, and try to go deeper and deeper. So yeah, that's how you're gonna be working on. Now, final, we've got to worry about the presence system. What is it? Okay, so presence system, right? Presence system. What in the heck is this thing? What's the purpose? Why are we introducing this system? Presence system is actually introduced for keeping track of when was the last time a user was active, or if a user is offline, how do we know that? That's why we use the presence system. So you would notice that there's a WebSocket connection from client to this system. Why is that? Because after a um, threshold amount of time, client sends a heartbeat that, hey, I'm still alive, don't count me out as an offline client. This is a you could call the presence system server, right? It actually gives a heartbeat. Hey, I'm still alive. Don't count me out. Then after 1 minute, it again sends a heartbeat. Hey, I'm still alive. That way, this presence system knows that, hey, this client is still active, it's still online. But what if a situation arises that even after 1 minute or a certain T threshold, defined T threshold, user is not giving any heartbeat? Then the presence system assumes that, okay, probably this client is offline, when was it last you know available? Was the last time it sent the heartbeat? These informations are going to be stored inside inside the Redis, the key value pair in memory database inside here. So what is its purpose? Why are we introducing this thing? Uh, for First of all, to understand whether he's offline or online or last seen, when was the user last seen, and this particular chat server also communicates with the present system. Why? To understand, to know, hey, is the user actually active? If it's not active, then I will give my service to some other client. So uh, during the application running, after a certain threshold, this chat server would also uh, try to communicate with the present system to understand that, hey, I have given user one my space, and if he's not available, then it's not efficient. It's not the service that I want to provide him. I mean, I have so many requests coming, and I want to save my places for the ones who are online, not the user one who is not off, who is offline, who hasn't been given the heartbeat for like what 20 minutes. So that's what's going to happen. Based on that, it would know that this user is not online, and the space will be open, and this memory, the data will be closed to, right? So yeah, that's what's gonna happen. So I hope I did make you understand it. I tried my best to do it, but please do take a look at the things that I uh, said about jumping on and searching on the internet. For example, consistent hashing and other things. So yeah, I hope I did make you understand about the high level concept of this modern chat application that you can try and build and build a big one, uh, yeah, an application capable of handling 50 million users a day. Okay, so yeah, that's pretty much from my part. Thank you very much for watching. It's been a wild ride of like what 3 parts I've made. This is the final part. So brace yourself. You're in for a ride, and I hope it's gonna be worthy of your time. So thank you very much.